is we are just going to list the radians where these happen. Our answers are always going to be in radians. And sometimes you might have more than one answer, which will happen a lot. On number 3, there's absolutely more than one answer because sine occurs at positive 1/2 in 2 places. It's up here above the origin, x or y is always positive above the origin. Also over here in quadrant 2. So what are the radians for where sine is a positive 1/2? The radians are pi over 6 and 5 pi over 6. That's the answer. That's what we're looking for here. So before I continue, let me kind of talk about this graphic for a moment. So this is the unit circle. I just printed this page from your chapter 3 packet. We're going to review some stuff I already told you. Remember, everything above the unit circle is positive for your y values. Everything down here is negative. I also told you guys a little mnemonic. You may have forgotten. I'm going to tell you again because it's pretty helpful. All students take calculus. That stands for the trig values where they're positive. So in quadrant 1, all the trig values are positive, sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent are all positive up here. What's positive in quadrant 2 is sine and cosecant. Down here, the only one that's positive is tangent and cotangent. And then the only ones that positive is in quadrant 4 are cosine and secant. Also very helpful to memorize how to get the numerators. In quadrant 1, all the numerators and the radians are just pi. Remember, in quadrant 2, the numerators are 1 less than the denominators. Over here, the numerators are 1 more than the denominators. And then over here, it's double the denominator minus 1. One more thing before we begin. If you notice down here, I wrote it in green marker. We're going to restrict our domain. Y'all, look at this inequality. We are going to include 0, which is the beginning of the unit circle. We're going to include everything all the way around up to, but not including, 2 pi, because the beginning and the end are the same thing. So we're not going to include answers for 2 pi, but we are going to include answers for 0. All right, so let's go ahead and keep answering questions here. So on problem number 4, it kind of goes back to what Miriam asked about earlier. We have tangent of -1. The only way that you can get tangent to be a 1 is if you divide it by the same thing. So what radians is it where the x and the y are the same thing? What is the denominator of the radians where the x and the y are the same thing? Good, it's a 4. I know immediately there's going to be 2 answers for 4. Now remember, in quadrant 1, everything's positive, but not in quadrant 2. In quadrant 2, you would have a negative tangent because you're going to be taking a positive divided by a negative. So my answer for this is going to be 3 pi over 4. And then also for the numerator of the 4th quadrant. Remember, the 4th quadrant is double minus 1. 4 doubled minus 1 is 7 pi. All right, let's go ahead and take a look at these bottom 2. This time, we want cosine where it's positive and negative. That means every time where you have cosine equals 1/2, whether it's positive or negative, we want to know those radians. There's 4 places where that happens because there's 4 quadrants on the unit circle. What is the first place where cosine is a positive 1/2? What are those radians? Perfect. Pi over 3. There's quadrant 1. Quadrant 2 is 1 less than. Quadrant 3 is 1 greater than. Quadrant 4 is double minus 1. Now we want to know the radians where sine is a negative root 2 over 2. How many answers are there going to be? For a negative root 2 over 2? There's 2 of them. Y'all, what is the denominator? So remember, where is sine negative? Sine is negative where it's below the origin. So it's going to be quadrants 2 and quadrants 3. I'm sorry, quadrant 3 and quadrant 4. So it is going to be 5 pi over 4 and 7 pi over 4. That's what we're doing, guys. Any questions on this? All right, then we're going to get started. Listen, go ahead and turn the page. Let's talk a little bit. I am going to write on a separate sheet of paper, but I do want to point out some stuff in this packet. First of all, here's your steps. We're going to work through these steps together. You are really not going to have to worry about this set of the instructions. That's going to be day 2. We're going to keep it pretty basic. It's A, B, and C. We're going to factor. We're going to isolate the trig function. We're going to combine like terms. Also, what you must remember, guys, is sometimes we're going to get like radians that are outside of the unit circle, and you have to say there's no answer based on the restricted domain. So this is restricted domain. Okay, one more thing. I am going to do problems 1 through 5 with you. I'm also going to go ahead and do problem 12 on page 24 because it's a reciprocal. And there's no reciprocals in your notes. So I'm going to do one of the homework problems with you. Also, your homework, you do not have to do problems 1 and 2. The only homework that you're going to have to do is numbers 3 through 11. And I am most certainly taking a grade on that. So, absolutely taking a grade on that. All right, let's get started. Again, I wrote my stuff on a separate sheet of paper here. Just want to make sure I'm maximizing my space. All right, here we go. Here's problem 1. What you need to remember is anything before the trig function can be divided. Anything after the letter x can be added or subtracted. Later on, let me just point this out, not today, but later on, you might have something that looks like this. That, if you notice, that is in between sine and x. That's actually part of the radians. So never, ever divide. Never divide if it's in between the word and the letter x. You won't have to worry about that today, though. Okay. Y'all, this is like a one-step equation. This is just like 2x equals 1. We're going to solve for x. So we're going to divide both sides by 2. Oops, so I'm going to just divide both sides by 2. And the 2 over here on the left is going to cancel out. So we have solved the trig function of sine x equals 1/2. But we're not done solving. We need to know the value for x. What are the radians where sine equals 1/2? There's 2 of them. Very good. 2 places above the origin where it's positive. Quadrant 1, quadrant 2. That's the answer. Not where you solved and isolated it. The radians are the answer. By the way, we always write in radians. So there we go. That's how we do it. Not going to deviate much from this. Let's look at problem 2. All right, so for problem 2, y'all, we have sine on both sides, the equal sign. You can't do that. We're going to move this over here. So look, I'm going to do it at the same time. I'm going to move this over here on that side. It's going to be a plus sine x. But at the same time, y'all see this negative root 2? This is going to move over here, and we're going to write a positive root 2. So let me recopy the plain sine x that was already over here. I'm going to move that over. Remember, when you move it over, it's going to be positive. So you need to write plus sine x. Recopy your equal sign. And then remember, we're moving this negative root over. So write just a regular root 2 because it's positive over there. And then from here, y'all, they are the same trig function and the same exponent. We're going to add them together. One of these plus one of these is 2 of those. So it's 2 sine x equals root 2. And then we're going to divide both sides by 2, just like we did in problem 1. So we want the radians, where sine of x is root 2 over 2. Is positive, you're going to have 2 answers. What's the denominator for this? Fourths. Nisha, what's one of them? Yes. Jessica, what's another one? Almost. It's 3. 3 pi over 5. 3 pi over 4. Quadrant 1 and then quadrant 2 is always 1 less. So that's a 3. Good job. I put you on the spot. But don't worry, Jessica. You are not the only one I'm going to put on the spot. I'm going to call on everybody. Except Hamza. Hamza knows his unit circle. All right, number 3. Let's take a look at number 3, guys. So for problem number 3, it's set equal to 0, all right. I don't have any terms that I need to combine. Y'all, we're going to subtract, or I'm sorry, we're going to move the 3 over. So it's going to be a positive 3 over there. And then we're going to divide by 4. And then we're going to take a look at what's next. So let's go ahead and move the 3 over. All right, I moved it over. Don't forget it's positive over there on the right side of the equal sign. Let's divide by 4. All right, look, y'all. See how it's cosine squared? That's just like x squared. What are we going to do to unsquare that? Good. What else do you always draw when you draw a square root symbol? Plus, minus. Yes, yes, yes. All right, so this is going to be plain cosine x over here. So we lost the exponent. And then y'all look, we're taking the root. 3's not perfect. So the numerator is going to stay underneath the square root symbol. But the denominator is perfect. What's the square root of 4? Yes. And make sure that it's not underneath the square root symbol, just a 2. Remember, you drew a plus minus. How many answers are there going to be? 4. 1 for each quadrant. Christina, do you know the denominators for the cosine root 3 over 2? The denominator? Mm-hmm. What's the denominator of the radians? 6. So let's put 6 down here on all of them. And then Miriam, let's do the numerators together. The first one's always pi. 1 less than the denominator. One more than. Double minus 1. There you go. Good job. Any questions on that one? So yeah, don't forget, y'all, if you square root, y'all did a great job of remembering the plus minus. Don't forget that. You did really good remembering. All right, number 4. All right, so number 4 has sign all over the place. You can't have that, so we're going to move this over. So I'm going to recopy sine squared x. I'm moving that over, so don't forget it's going to be negative. So write minus 2 sine x. And y'all, there's nothing over there anymore, so write 0. And then, does anyone want to take a stab at what you think we should do now? We're going to factor. Good job. Let's factor sine x out of both terms. All right, so there's 2 of them. We took one out. That's going to be plain sine x right here. And then there was one of them, we took it out completely, so this is going to be minus 2. And then, just like algebra, when you factor, we're going to set each factor equal to 0 and solve. So it's going to be sine x equals 0, and then sine x minus 2 equals 0. Solve. Well, this one's already solved. But this one isn't. Let's move the 2 over. So this is going to be sine x equals 2. All right. So think about the unit circles. Jack, you ready?
Yeah.
All right. So where does sine equal 0 on the unit circle?
2 pi.
Perfect. What else? Perfect. And remember, 2 pi and 0 pi are the same thing. But according to the problem's restricted domain, we're only going to have 2 answers. We're not going to count this twice. So he's right. X is going to be 0. We're not going to write 2 pi because it's out of our domain. And then the other one he said was regular pi, and that's right. All right, all of you guys, where does sine equal 2? Where do we have a y value of 2? Nowhere. Y'all, the highest y value we ever get is a positive 1. So this is beyond the unit circle. Good job. So there's no answer because it's outside of our domain. So our only answer is right here. I would, when it comes to extraneous, you could write the word extraneous, or just make sure I know that you know it's not an answer and why it's not an answer. All right, number 5. Okay, so for problem number 5, it's a cosine problem, and they're all on the same side of the equal sign, which is great. I can't combine these though. Oh, I apologize to you. That 2's in the wrong spot. Sorry. Remember, the exponents are right there. So they don't have the same exponent, so I cannot combine them. But y'all, you can factor it. Look, in your head or on your paper next on the side, write 2x squared minus 3x plus 1. You're going to factor that just like you would do that. You go ahead and factor that in whichever method you prefer. I'm going to factor it also. All right, so look, when I factored this little baby algebra 1 trinomial, I got these factors. Y'all, it's going to be the same thing. We're just going to put cosine with it. So our first factor is going to be cosine x minus 1. My other factor is going to be 2 cosine x minus 1. And then what do? We set each of them equal to 0 and solve. So we're going to have cosine x minus 1 equals 0. And then 2 cosine x minus 1 equals 0. Let's solve. Think about all those radians where it equals. Michaela, I'm picking on you. It's so exciting. All right. Do you know where cosine of x is 1?
0.
Perfect. Yes, yes, yes. Do you know where cosine is 1/2?
5/3.
Yeah, and?
And 5/3.
Perfect. Great job. That's 100 from Michaela. Any questions on how she got that? All right, y'all, let's do number 12. Let's do one of those reciprocals. It's easy. It's just a little baby step. You got to think a little bit. You're going to be all right. All right, so on page 12, I'm so sorry, problem 12. It's page 24, right? Okay, page 24, problem 12. All right, so we are going to solve secant. Definitely going to be factorable. I know I can't combine like terms. Y'all move the 2 over. Set it equal to 0. So it is going to be secant squared x minus secant x minus 2 equals 0. Okay. And then remember, we're going to factor this just like x squared minus x minus 2. All right, so it's going to be x minus 2 and x plus 1. But remember, we're going to write secant in front of those x's. So secant x minus 2, secant x plus 1. Set them equal to 0 and solve. All right, cool. Y'all, what is secant the reciprocal of? Cosine, yes. So, this is just cosine flipped upside down. Flip them upside down again. So we're going to find cosine, and that's going to be our answers. But we're going to flip these. What's 2 flipped upside down? Yeah. So we're going to find cosine of 1/2 and -1. Y'all, what's -1 flipped upside down? It's just -1. That's right. Good. So x is going to equal, for this +2, for secant, you're going to have 2 answers where cosine is 1/2. Ian, do you know those radians for 1/2? And 5π/3. Great job. Hamza, you knock out the -1 for us. Where's cosine -1? Perfect, pi. That's it. 3 answers on that.